Okay.
Yes,
So, Prahlad, so now tell me how you define manufacturing process.
sir, manufacturing processes are those processes in which a raw material is converted into a desired product.
Mm-hmm.
So actually, we can say them from converting raw material into a useful product. The processes we use that are the manufacturing processes. We can define in that way.
Okay.
Yes, sir.
Okay. So, and how it is different from production?
That in production, generally the management science also comes into picture.
Mm-hmm.
From manufacturing, as with the manufacturing point of view, the management of the processes also comes into picture. So that
Mm-hmm.
becomes production technology.
Okay. Okay. So, how you define flow stress?
The flow stress is the stress required to make the material to flow plastically deform.
Mm-hmm.
So in this way, we can define the flow stress, sir. Stress required to deform the material plastically. That is flow
Okay.
stress.
Plastically. And what do you mean by recrystallization?
Then in the recrystallization, the deformed grain, which are
Yes.
mm, have been become deformed due to cold working or whatever process. So those deformed grains recrystallizes, means they regain the new grains are formed, new stress free grains are formed. So
Mm-hmm.
basically in recrystallization, what happens, the old grains are converted into new stress free grains.
Mm-hmm.
And
Okay.
if we keep
Yes,
the
yes.
temperature, yes sir.
Yes, tell me. Continue.
Yes, sir. If the temperature is maintained for a longer time, then the grain growth also happens in the
Okay.
recrystallization. Yes, sir.
Okay. And what is the difference between cold working and hot working?
Sir, uh, if the process is done above the recrystallization temperature, generally we
Mm-hmm.
call it a hot working process. And if
Mm-hmm.
the processes are taking place below the recrystallization temperature, then we call it is a cold working process.
Any other
So
difference?
it is the basically the recrystallization temperature that differentiate these processes. So in a cold working, we get the
Mm-hmm.
higher surface finish than hot working, and also the strength of the material is also good in cold working than the hot working,
Mm-hmm.
and the dimensional accuracy we get, that is also good in cold working, sir.
Okay.
Yes.
And which process produces much accurate object than if you compare with hot working and cold working, then which process produces better object, better dimensional accuracy and surface finish?
Sir, it is the cold working process, or under the category of cold working processes, we have the forging, which produces
Mm-hmm.
the strongest component than the other casting and other manufacturing processes.
Mm-hmm.
So the forging is the
Okay,
one
let's
technique.
suppose if you want to make a crankshaft, so how you manufacture it?
Okay, sir. So, sir, in the manufacturing of crankshaft, we can use the extrusion process, and also the rolling process can be used.
Rolling process,
Yes, sir.
extrusion process. With the help of extrusion and rolling, can you manufacture a crankshaft? How it is possible? Tell me. Do you know what is how it is visible?
Okay, okay, sir, sir, sorry, sir, sir, I thought a circular shaft. So
Mhm.
that, so sir, sorry, sir, for that. And crankshaft
Mhm.
can be like it is generally made by the forging process, sir.
Mhm.
So crankshaft and connecting rods, these are the made using the forging, sir.
Okay. Anything else?
That's it.
So, what are the steps involved in the forging process for the production of crankshaft?
Sir, first step in forging is the raw material is squeezed between the dies.
Hmm.
These dies can be open or closed dies,
Hmm.
and then the pressure is maintained,
Hmm.
and sir, then die opened and the product comes out, sir.
Is it possible? Okay, what do you mean by full ring operation?
Sorry, sir.
What do you mean by full ring operation?
Yes, sir. I have studied that these are 4 or 5 steps in the forging operations. So, sir, I
Hmm.
have forgot. Uh, I'm not able to recall that, sir.
Okay, and what is piping defect? Hmm.
Sir, it is a kind of forging defect,
Hmm.
but sir, the actual meaning of that I'm not able to visualize this.
Okay, and what do you mean by cold set defect?
Cold set defect is, sir, it's a casting defect when the two metal streams do
Yes.
not fuses properly, which comes out from different gates, but they meet, but they do not fuse properly before solidification. So that becomes the defect for in casting.
Hmm. And how to eliminate these defects?
So to eliminate the cold set defects, we can increase the pouring temperature, sir,
Hmm.
to improve the fluidity of the molten metal. So one thing
Yes.
that we can do, and,
Hmm.
and sir, basically the fluidity it plays the major role in that. So whatever are the ways of increasing the fluidity, that will be
Hmm.
helpful in overcoming this cold set defect, sir.
Okay. And what do you mean by blowhole defect?
That blowhole defect is also casting defects. That is also due to the entrapped gases in the castings. When
Hmm.
the gases are dissolved in the molten metal, but when the molten metal is solidifies, the
Hmm.
gases, dissolved gases are comes out and they are entrapped on the surface of the casting, and they make the hole a larger hole. So that is a blowhole.
Hmm. Hello.
Yes, sir.
Okay, Prahlad.
Yes, sir.
अच्छा, टिक वेल्डिंग में कौन सी पोलैरिटी यूज करेंगे?
Sir, tungsten arc welding generally we use both polarity, direct current state polarity as well as direct current reverse polarity also. That depends
हम्म
on the material we are welding, sir. Like for
हम्म
aluminum and magnesium, we use the generally we can use the direct current reverse polarity also, but we prefer the AC current for that.
हम्म।
But for other alloys, steel alloys and other alloys, we can use generally we use the direct current state polarity.
ओके।
Yes, sir.
And how to initiate arc in TIG welding process?
Sir, to initiate the arc, generally we use the tungsten electrode. That is
I'm asking how to initiate. I'm not asking through which you can initiate. Obviously, tungsten electrode यूज कर रहे तो उसी से करोगे ना. But
yes, sir.
आर्क जो इनिशिएट हो रही है उसका मैकेनिज्म क्या है?
Sir, when electrode touches the workpiece
टच करेंगे,
and
you can see. In TIG welding especially when you use non-consumable electrode.
sir, there is a ionized flow of sir, there is a we maintain the limited gap between electrode and workpiece. When the current is applied between electrode and workpiece, the gap is ionized and the flow of
How to
ionized.
initially you have a gap between electrode and workpiece,
Yes,
correct?
sir.
And if you have just gap between electrode and workpiece, then when you supply current, then how arc will initiate?
Sir, I am not able to, sir, recall that.
Okay. Okay. Can you define tool angles?
Yes, sir.
Single point cutting tool angles according to ASA system.
Yes, sir. Sir, according to American Standard Association, we have the 6 type of angles, like back rack angle, side rack angle, and the
Acha, what is
and
rack
relief.
angle?
Sir,
What is
rack
rack?
angle. Yes, sir.
How you define rack angle? Tell me.
The rack angle is the uh, angle between the tool surface and the perpendicular to the workpiece surface. So that is the angle between perpendicular to workpiece and the tool surface, sir.
Not
So
it is. It is not clear.
Sir, like we have the tool rack face. So it is the angle between tool's rack face and the perpendicular, which is drawn perpendicular on the workpiece.
Okay.
Yes, sir.
And similarly, how you define clearance angle?
Yes, sir. Sir, clearance angle defined angle between the tool's flank surface and the workpiece surface.
Okay.
Yes, sir.
And why we do merchant force analysis?
Sir, using the merchant force diagram, we can find the other forces like shear forces and if we if we know the if we know the other forces, then we can find out the other forces also. Like if we know the cutting and uh, thrust forces, we can find out other forces like shear
हम्म
forces and the friction forces and normal forces. And
हम्म
so in that way, this is the equilibrium force diagram that help us to find out the other forces.
okay. Okay, Pralas, so now I'm going to conclude your interview, correct?
Okay, sir.
अभी आपकी प्रिपरेशन उस लेवल की नहीं है, ठीक है ना, करेक्ट आंसर नहीं कर पा रहे हो।
Okay, sir.
इवन मैंने कास्टिंग, वेल्डिंग, फॉर्मिंग सारा कुछ कवर करने की कोशिश किया, करेक्ट, एंड इवन मशीनिंग, करेक्ट है। तो थोड़ा सा इसको प्रॉपर वे में पढ़ना पड़ेगा। जैसे मैंने पूछा व्हाट इज रैक एंगल, तो आपने बोला परपेंडिकुलर है इधर उधर एंगल। आप सिंपली बताओ ना, इट इज एंगल फॉर्म बिटवीन रैक सरफेस एंड द रेफरेंस प्लेन, देन दिस इज कॉल्ड एज रैक एंगल, करेक्ट।
Yes, sir.
तो थोड़ा सा आपको इस पे अभी वर्कआउट करने की जरूरत है। तो पहले एक बार ढंग से आप स्टडी करो, और जब एक बार कंप्लीट स्टडी हो जाए तब आप मुझे बताओ, ठीक है।
Yes, sir.
तब आपका फिर
Yes.
से दोबारा इंटरव्यू रखिए, है ना। तो
Okay,
थोड़ा
sir.
सा तसल्ली से पढ़ो, 2-3 सब्जेक्ट प्रिपेयर करो, लेकिन अच्छे से करो उसको।